Hello everyone, welcome to today's lesson. And today's lesson we are going to look at soils. One will ask, what are soils? Before I continue, I'd like to welcome you all and please pay attention as we start this lesson. Please silence and listen. This is very important. Geography needs to be respected and pay attention. Diana, in the corner, please pay attention. Come on. Here we go. What are soils? In geography, we teach about soils. So today we want to break down and understand a little bit about soils. At the topic you see it up there, it is soils. And actually, in most cases, we cover soils after the topic known as, and I'm telling you, it's always common to people, and that is weathering. Immediately after weathering geography, we go on to soils. So in today's lesson, we are looking at soils, as you see the topic up there. So let's start straight away. And first of all, we need to define what are soils? What is soil? And today's definition, you and me, we can agree, whatever you have there, is that soil refers to a thin layer on the earth's surface on which plants grow. It is made up of organic matter, living organisms, air, and water. Most of us have done these experiments in biology and we understand this. So in geography today, we're just going to look at that definition. As we say, it is just a simple thin layer on the earth's surface on which plants grow. You and me, we survive on this. Animals survive on this. Plants survive on this. And human being, we eat food that grows on soils. That's why it's important in geography to look at what soil is. So we continue to say it is made up of organisms, as we have seen, air and water. Organic matter in this context, that is that this is just living organisms that actually die off, decompose, and form organic matter. Because organic is what has life. And then living organisms, you and me, we have seen snails, we have seen insects within soil. Then air, we did that experiment where you get a block of soil and put it in water and bubbles. That is air in soil. Then water, basically, what helps a plant to grow? We look at photosynthesis, we look at many other things, but the most important thing is here is water. So soil contains all this. So we continue and say, what forms soil? As I told you, we cover soil immediately after weathering. And it is weathering in this process that forms soil. It's the fundamental process that breaks down the rocks and forms that thin layer on top of the earth's surface. So weathering in this process is that. Weathering is the process of soil formation, followed by erosion, transportation, and deposition. And let's note this, please. Weathering is the disintegration stroke breakdown of rocks into small particles, into situ, or in one place. Situ just means that when it is broken down, it's left in one place. So let's break down weathering very well. In the previous lesson, we looked at it there. But as we have talked below here that we have erosion, transportation, and deposition. So these processes come into place and move this soil to different kind of places, as we shall see. Because erosion, as we shall see, is the wash away of topsoil to another place. Then as it is washed away, what transports it? Agent salts. So erosion, as we shall see, we have wind, we have water, and we have animals. Then deposition, where it is deposited. So we need to break down weathering. As in the previous lessons, we have already looked at weathering into different processes of chemical, biological, physical, and many other processes. So we shall not move into that right away. Let's just continue with this. We are saying that when we move on, we look at the different segments of soil. We need to understand this. One is the soil profile. What is soil profile? First, we have looked at what soil is, it's in there, and where plants grow. Then we need to move into and understand the concepts that make up soil. And we are looking at one that is soil profile. What is soil profile? So we are saying under into our little definition here is that soil profile is the vertical arrangement of soil particles in layers, stroke horizon, forming the surface of the earth, down towards the bedrock. So it is the vertical arrangement. Vertical means top to down, down to top. It's vertical, not horizontal. Get this clear. It is the vertical arrangement of soil particles in layers, stroke horizon, forming the surface of the earth, down to the bed rock. Maybe you can understand it clearly with this illustration. So let's look at it. Let's briefly look at it. So this is our simple illustration of soil profile. This is what I could get best. We have the top, the humus layer, where we see plants, decomposed kind of materials here. So organic matter, this is what we talked about initially. So this kind of black layer that you see, dark black layer here is the organic matter. So it is loose and partly decayed organic matter that is from the plants, the organisms and mentioned. But if you then we come down here to a horizon where we have mineral matter mixed with some humus, as we shall see. Then we have here the E horizon, sometimes we call it the B horizon, light colored mineral particles, zone of elevation and leaching. As we shall see, we shall also understand the process of leaching here. Then B horizon, accumulation of clay transported from above. And then C horizon, partially altered parent materials. And then when we come to the D, or this other one is the unweathered parent materials. Oh, these are the bigger rocks that are still intact, that are not yet weathered down. So we have those that are partially weathered and those that are not yet weathered. So as you can see, it is just the vertical arrangement of the soil from top to the bedrock down here. So we need to understand this, please. Take a moment and understand this, that as we shall see, we have two. Here we have the soil profile. We're going to look at the CATENA now. But now let's understand the soil profile. Once again, we are saying it is the vertical arrangement of the soil particle in layers, horizon, forming the surface of the earth, down towards the bedrock. Are we together on that point? Can we move on? Good. So we're saying, as we move on, we are now looking at what they call soil CATENA. Previously, we've been looking at soil profile. Now we are on the soil CATENA. Are we together on this? So on this, now we're defining it and saying, soil CATENA is the sequence of various soil types from hilltop to the valley down the slope. Here it is horizontal. Previously, it was vertical. It is the arrangement of soil down a slope. It varies with relief, drainage, and the parent rock. Mark this, don't mix the two. Initially, we looked at soil profile, which was the vertical, but now we're looking at the CATENA, which is horizontal. And when you look at the CATENA right now, this is how it can look like. Briefly, I was trying to get this illustration. From the hilltop to the valley, as we can see. Those who have walked hills on hilltops, or from the valley to the hills, you have seen the difference in the soil. That on top, we kind of have some kind of stony, rocky kind of soils. Then as you're coming down, we're having kind of the loamy, kind of fertile and mature deep soils. Then as you're going to the valley, we are going to see the swamps. That's the kind of waterlogged soils. And then very waterlogged within the swamp itself, Because why? As water is coming, it comes from up here and then moves down to the valley. And the valley becomes the catchment area. That's why we have the very waterlogged. And you'll never find a swamp on top of the mountain or on top of the hill. Sorry, it's down the slope. So, soil CATENA is a sequence of various soil types from hilltop to the valley down the strip. Now, the various soil types here that we're talking about, we have said on top, we don't forget the sandy, stony, rocky skeletal soils, which normally influence the growth of thicket and shrub kind of vegetation on top of hills. And then as we come mid slope here, we have the stony also. And then as we come to the gentle slope here, we get what we call the deep kind of lynched or alluvial kind of soils, and loamy soils. Sorry with that. Then we come down here where we get partially waterlogged soils next to clay, and there is gray in color and clayish in color and reddish in color, and then in the swamp. So basically this is how it looks like. Let's continue on two other concepts. So briefly, we want now to look at this diagram that tries to show us the two, soil profile and CATENA. We have the poorly drained soil profile and well drained profile. So looking at this, it brings out what we've been talking about. So on top here, we see the trees, we see the grass, and we see that. So we call it B horizon, and then the exposed R horizon. And then down in the valley, that's where we have our swamp, and then the swampy vegetation and the clay kind of soils. So this is what we're talking about, that you are going to find the well-drained soils up here have thin A horizon, thick E horizon, and clay kind of rich B horizon and C. Then on the poorly drained kind of soils, well, we have lots of water into it. We have the well kind of saturated and thin A horizon, as we shall see here. So this tries to show us the difference between the two and how it looks like. We're trying to make a cross section about it. We can continue here to have a real view of what we are talking about. So this is trying to show us the real view of the soil profile. I dug my pit and tried to take a photo of this. When you look at this, these are plants, and this is the dark kind of soils, and this is where the organic matter is, and then this is the humus kind of area, and then we go to the B horizon. Even same applies to this one. This is a little mature kind of soil profile, where we have again the vegetation. We have the dark kind of part of soil, and this is the humus layer, and then we come to this other bit where we see this soil fully formed kind of soil. So this tries to show us what we are talking about. So if we go today and you dig a pit at home, you get to see this. So this is what they call soil profile. Let's move on and look at the real environmental view of the soil CATENA. This is now the view of the soil CATENA that we've been talking about. Previously we were looking at the profile. Now I want to look at the CATENA. It's the cross section of our hill. So we are saying up here we are looking at coarse sandy soil, stony, basically thin soils due to excessive erosion, wash away of the young and newly formed soils down the slope. So as you can see here, that on the foot slope we are having a little mature soils, and actually it is influencing our vegetation. Then when we come down here, we're going to have clay. Why? Because of the waterloggedness in this area. And why? Because the elevation of this, it is at a low elevation, and that's why water comes and settles. So we see water coming up from the top of the hill down the slope, making this area waterlogged. And that's why we have the clay kind of what? Soils. So this is how the soil CATENA looks like in our normal kind of life. Just we did a cross section about it. So this gives us the great picture of the two that we're talking about. The profile, which is the vertical arrangement, and then the CATENA, which is the horizontal arrangement. Vertical is from the top, that is the soil profile. Vertical arrangement from top, the earth surface, to the bedrock. Whereas the soil CATENA is the arrangement of soil from hilltop, different soil kind of patterns, to the valley. Mark that difference. It is very important because at the end of this lesson we'll have questions to answer. We move on. Our next area is soil erosion. We have covered what soils are, but we need to understand that soils, after being formed, as we talked about initially, that we had where we have erosion, transportation, and deposition. So we want to move on to soil erosion because initially, after covering what soil is, the profile and the CATENA, we introduce ourselves to soil erosion. It's one of the effects that we have that is actually making most of the land kind of unproductive. So we on soil erosion. Let's understand this. Soil erosion, as we shall see briefly, is just the washing away of topsoil by the agents of soil erosion, such as running water, wind, and living organisms. It's made up of two words, soil and erosion. We have seen what soil is, and it's made up of profile and CATENA. We have said soil is just a thin layer where plants grow, and it has in it organic matter, air, water as its components. It is formed by a process known as weathering, breaking down the parent rocks into small kind of particles to form soils, plus the organic matter that mixes up with the weathered material. So they want to look now at soil erosion. What is erosion? When you go to the dictionary to find out what erosion is, it's just the removal of something from one place to another. At this point now we are looking at how soil, after being weathered, is moved from one place to another. Soil erosion. So we are saying soil erosion is the washing out of topsoil by the agent of soil erosion, such as running water, wind rains, wind, storms and strong winds, living organisms, cattle, goats, people, nation. As we walk on the soil, we are doing erosion. So we are saying, as we need to understand more about this concept, that we have types of soil erosion. And one is wind erosion. From the agents, what is wind erosion? This occurs when soil are left bare, leading to drying of topsoils, which are transported by the power of strong winds from one place to another. As we said initially, erosion is just to moving things from one place to another. And what is moving this? It is wind. And wind is moving what? Soil. When you leave the soils open, you expose them to agents of soil erosion. That's why at school we tell you, please plant grass, plant trees, as we shall see in our next experiment. So we are saying here, this occurs when the soil is left bare, exposed to the strong winds, which blow, as we shall see. Then that is type number 1. We want to move on to, it is said that in East Africa, this kind of type is common in northern Kenya, central Tanzania, and Masai land. Why? Because those areas are exposed. They have little kind of vegetation cover. Type number 2 is known as splash erosion. This takes place when raindrops hit the ground and the splash water removes soil particles. We shall have to understand this with a kind of a visual aid ahead. First, I need you just to know the definition and to understand this. So splash. When it rains, as we shall see, we have what we call raindrops. Do not underestimate the power of a raindrop. It hits the ground, causing the soil particles to move, to shatter. That's what we call splash. Then gully. Number 3. Number 4, number 3. Gully. This is more advanced, where water enlarges and deepens the channel, changing them into big valleys, as we shall see. Gully erosion. So if you ask the types of erosion, we are saying we have number 1, as we have seen, we have more than 1, and those are 5 types of soil erosion. And we are saying we looked at splash, we looked at the wind, now we are looking at gully, and one complete with this other one, which is rill plus ship. Rill erosion. This is the removal of soil by running water in tiny channels, for example, around our verandas. You've seen these channels. In dark shape that you see there is a simple video that I want you to look at. But before we look at it, let's look at also sheet down here. Sheet erosion. This involves a uniform removal of thin layer of soil particles from a large area by surface runoff. Just get your piece of paper. That is a sheet of paper. So this means that erosion is taking place on a large area, uniformly, as we shall see in the video below. So the video in between here is trying to show us the power of water. As you hear, detachment begins of erosion. Watch carefully. I think you can hear the sound of the rain. That is water. As you see the video right now, it is water mixing up with soil. And as it is mixing up with soil, some particles are saturated into the soil, into the water. You can see now these are small channels. It's raining. I think you can hear the thunderstorm. It is now moving down the slope. As it is moving, it is creating the simple channels. As it is moving, this is the power of water. It is eroding. It is going with particles. You see that particle, that particle, that particle, that particle. That's all. So now it is transporting, as we said initially. You see all these particles? They are moving down the slope. They are moving, and that's what we call erosion. Water. So small particles are moving within the small channels. Now when you come down here, it is on a large scale and it is depositing it, this other area here. That brief video here was able to show us how water is able to move into small channels and moving what? Moving soil, depositing it down. So I want us to continue below and look at this. This is what we looked at and said wind erosion. This is wind, as you can see in the photo. Blowing soil. The same applies to it down here. Wind erosion. Because the soils are left bare, as you can see in the photo, down and above. So this wind is blowing, heavy storms of winds are blowing, strong winds which erode the soil. And this is wind eroding soil. Thus we call it wind erosion. Then on this other hand, on my right hand, I see gully erosion. It's a picture to show us how gully looks like. So it opens the small channels into bigger channels. They were initially small, but due to the large quantities of water, they erode the soil, creating a bigger and bigger channel. So those are the few kind of visual aids which can help us to understand what we're talking about. Erosion takes place. As you can see, the area is still okay, but with time, when erosion acts on it, the top layer is washed away. Have you seen the green part area? Top layer is gone. Just look at it. It goes. So have you seen the productive area? The productive soils are being washed away, leaving the unproductive soil there. With the time, if we don't act on it, it will leave the unproductive area. So as you can see in this video, we have what we call wind. We are trying to animate to show you how wind erosion takes place. So as you can see, the movement of this wind goes with the small particles on the surface of the area, which is left bare. As you can see, this area is bare and the wind is moving. If it goes around 20 meters per hour with the intensity of that kind of wind, it can easily sweep away the small particles with the movement of the wind. As you can see, it is moving with the wind. That's now what we call wind erosion. So in this now, we are looking at the impact of raindrops, as you can see now on water erosion. As rain drops down, do not underestimate the power of the raindrop, which is falling about 30 meters per hour. Around, it can take soil of about 100 tons per acre. So as it comes, it drops with the intensity and the power, and it splashes away. It shatters. It dismantles the soil that finds on the ground. And this is common so much during rain. As you can see in this video right now, the kind of the small channels where now water is moving are the ones that we saw previously that lead to real erosion. So in the 5 types of erosion we talked about, where we talked about sheet, reel, gully, wind, and others. So one first of all understand what sheet erosion is. As you can see here, that a whole big area is taken off. We are trying to show an example of paper and the soil here. It's swept off. Now you can see this big chunk of land. Sheet erosion acted on it. It is eroding a bigger area, actually leaving it unproductive. So here is sheet erosion. A bigger area has been eroded. Now when you come to this area, we look at reel, the small channels where water is moving, where water is eroding, as you can see. Then this kind of erosion is known as epithermal kind of erosion, where it is close to the river banks and water bodies, where it widens the small the small channels into long and surface areas. So this takes us to gully erosion. As you can see, erosion has acted on the small channels, expanding them, making them bigger. This we call gully erosion. Trying to show you an example of what it looks like. Now we have what we call stream bank erosion. This erosion just to the streams Next, the lakes, where the rivers connect with the lakes, where the rivers connect with the swamps. It goes and washes away the banks of the river, the cliffs of the river, with the force of the water. That's what we call the stream bank erosion, which we didn't look at previously, but this can help us to understand that better. So briefly, that concludes. What is soil? Question 2. Define weathering. Question 3. What is a soil profile? Question 4. Illustrate a soil profile. Question 5. Define a soil CATENA. Question 6. Illustrate a soil CATENA. Question 7. What is soil erosion? Question 8. Identify the agents of soil erosion. And lastly, question 9. Describe the types of soil erosion. Please, I leave this assignment to you. Answer it in our next lesson. I need that one.